All right. So, about a year ago or so, I visited a college campus mechanical engineering workshop that there's about four drill presses in there or so, and I was there for about a week. And about halfway through the time I was there, they replaced one of the drill presses with a brand new one. And this brand new drill press that they brought in was controlled entirely by a VFD. There was no belts to switch or gears to adjust the ratio of or anything else. So and I thought that was just the freaking coolest thing I'd ever seen. When I saw that VFD controlled drill press, I thought, dear God, we're living in the future. So I decided I had to have one of my own. So I built one, and this is what the monstrosity looks like. So this is pretty much cobbled together from the existing drill press I had and some eBay finds. So this VFD right here can be found on eBay for about $100. At least it was $100 last year when I bought it. I don't know what it is now, but it's actually a pretty comprehensive VFD. It has it's a vector control, or it has a vector control option, I guess I should say, which gives quite a significant torque boost at low speeds. When I first put this thing all together and I was testing it out, I was really disappointed with how poorly it performed at low RPMs, like extremely low RPMs. But it turned out that I had it in VF mode instead of vector control mode, and so switching it over to vector mode really improved the low speed torque on this thing. But yeah, so that's kind of the heart of the whole thing. But so that VFD controls this motor here. So initially, the motor that came with this was a single phase 120 230 volt motor right here, 3/4 horsepower. So I think it's 3/4 horsepower. Yeah, 3/4 horsepower. And the problem with that motor is that it's single phase. So for a VFD, in order for a VFD to be able to properly control a motor's speed, it needs to be three phase. So there's a few problems there, right? Number one is, well, I didn't have a three-phase motor. Number two, I don't have three-phase power being supplied to my house. Well, this VFD generates three-phase power. So the only thing it needs is a 230, 240, whatever volt input. And so I figured the easiest way for me to do that was simply to use a step-up transformer. So combine everything together, you have 120 line voltage going into a step-up transformer, which converts that to about 240. I have that going up here into the housing. And we'll open up this housing real quick. If I get back there. And I've just got the wire running inside there. Now you'll see it's still controlled by, or it's still driven by belts. However, the hope is that now I don't have to move these belts around quite so much anymore. Used to be that whenever I would have to, if I was drilling hardwood or aluminum or steel or plastic, I'd be moving those belts around. Not too often, but often enough, and so now it's nice to be able to not have to worry about dealing with that anymore. Anyway, so the line comes right in here, and I had to drill two additional holes here to the side of the, oops, that'll focus, to the side of the VFD, and it comes out. And the line voltage simply goes down here and connects to the terminal block. All right. So I think normally household 240 or 220 or 230 or whatever it is actually the combination of two. It's the constructive um, sum of two hot 120 legs, right? So in this scenario, we just have um, a single hot leg, and that one hot leg is 200 and technically it's about 230, I guess, volts coming in here, and then that's the input, and then we have uh, the three phase output right here, and this three phase output comes back up, goes into the housing, and comes out right here and attaches to the motor. And the motor is wired up according to the schematic diagram on the back there for low voltage setting. So this motor is a 3/4 horsepower, three phase, 230 slash 460 motor. So the low voltage setting is the 230 on that. So, and it works pretty good. It works really good. I was doing some testing earlier today, and I gotta say I'm pretty pleased with the performance. So all you have to do is hit run here in order to start it. So right now I have it. You can configure the display of this thing to display pretty much anything that you want. So this number right here is telling me the percentage of torque that the motor is currently experiencing. Right? So it looks like we're hovering at about 30% right now. You can see if I grab onto the chuck, I can increase it a little ways there. I've got it geared pretty low so that the maximum speed is 1,000 RPM when the VFD is cranked all the way up to the max. And this is, it takes it a few seconds for it to spin up, but it does a pretty good job. And this is I think it's a 34 or 3500 RPM motor. Let's see. Yeah, 3485 RPM motor. So it's, it's got a pretty good reduction going on. And I think generally speaking, 1,000 RPM should be low. I might increase the ratio just slightly to give me maybe up to about 1,500 RPM if I want to do some spindle sanding or something, but I think that should be fine for most purposes. It also gets pretty loud once it starts cranking up. I think those pulleys might be a little unbalanced after sitting so long in that in the same configuration. It's especially noticeable if this thing's closed. Kind of reverberates inside there. So you can press off. So I think this thing has support for a braking resistor that hooks up to P plus and PB here. I don't currently have one installed, and in fact, the ports for it are there, but they're not cut out up there. So, and I don't remember. I got this thing about a year ago or so. I don't remember if I cut those out or not for the other terminals I was hooking up to. But the manual suggests a 100 ohm, 100 watt resistor for this particular VFD and the conditions it's being put under. So, but I mean, I don't know. I don't know if that's really necessary. I have it set so that it isn't really using any, like, it's not, it's decelerating entirely due to mechanical friction right now, instead of actively being braked via the VFD. So I don't think it's necessary. I don't think I'm going to put one in there. But so in theory, this thing could, pretty much stop on a dime. If it ran into if you had it configured that way for some reason, once you turn it off or whatever, which I don't know if that's an ideal. It's probably not an ideal configuration for drill press. So, but anyways, this thing also has a light switch. I don't currently have that hooked up yet. I think what I might do is make this into a 2-switch gang right here, with one switch being the light switch and the other switch being a jog control for this, because the nice thing about a VFD is you can also reverse direction, right? So there's a little indicator right here, DIR, and this thing has I swear, if you look in the manual, it's probably got at least several hundred or maybe even 1,000 configuration registers for all sorts of different parameters and such. And so one of the configuration registers is the direction of the motor. And so once the direction is in reverse, this little thing right here lights up. And then it spins backwards, obviously. So it would be nice if there was a little jog here, and if you had it in the... I don't know exactly how the jog works, if it needs to be in the run state, or if you could... I guess it would need to be in the run state, right? But if then you can just kind of like jog it up or jog it back, for if I was tapping, for example. Tapping like a cast iron or an aluminum piece of plate or something like that. I hate tapping manually. It's a pain in the ass. It's a lot nicer on the drill press because everything, you got the tap that's perpendicular to your surface or to your piece that you're tapping here, and it just works out well as long as you can have fine grain control over it. If you don't have that fine grain control, that's how you get broken taps. The light itself is expecting 120 volts. The problem is I don't have access to 120 volts anymore, right? Like I said earlier, this is going through a step-up transformer, which means that there's only 3 wires inside of this thing. There is hot, neutral, and ground. And the hot's at 240, and ground and neutral are both at 0, and so there's no 120 to be found. So I think the easiest thing for me to do is to simply replace the bulb inside here with a 240 volt rated bulb to have that functionality again. And this thing has a bunch of different features. So I could have there's a terminal communication block inside there, right above the primary power block, and there's a bunch of analog and digital inputs and outputs. And so in theory, you could have one of those analog outputs, control a relay or something that turns on the light, whenever you have it start. Although, in reality, I probably want to be able to control that separately, because what I like to do is turn on the light as I'm positioning it, or kind of maybe working on it a little bit here before I actually start the press, or start the drill. So, yeah. But, yeah, it wasn't, in total I probably spent maybe a little over $200 or something on all this. You really, it was the VFD, the motor, and then the step-up transformer. The step-up transformer and the VFD I got on eBay. I got a really good deal on the step-up transformer. It was, maybe $20 or something like that. And then the VFD, the motor I got from Zorro, which in retrospect I should have gotten that from eBay. If I would have gotten it from eBay, this whole build would probably be about $50 cheaper, or so. And then The only thing I had to do was this shaft on the old motor um, was larger than the shaft on the new motor that I got. But I wanted to use the existing pulley system. I didn't want to have to find a new pulley system to put on. So I went ahead and ordered a shaft. It's basically like a shim that sits over the shaft there, and that worked out really, really well. That allowed me to, in fact, I don't know, maybe you can see it in there. There's like a shim that's going around the motor shaft, and it's also got a key that came with the shim. So that locks it in place really nice. It was a little bit offside, so it kind of sticks that shaft. The motor shaft is actually, down there's a little ways, but I think it's fine. I don't think it's going to move at all or come off at all. Like I said, I've got this thing geared right now, so it's at the original setting, it would have been 430 RPM. And since this new motor I got, it's about twice as fast as the old motor that came out of here. I get about 1,000 RPM in this current configuration, and plenty of torque, lots of torque. When I first hooked this up, I had forgotten to hook the ground back up to the stand, or to the actual press itself. The ground was just going into the VFD, and I turned it on and I touched the plate here, and I could definitely feel that static buildup on there. The VFD, it says in the manual too, it's extremely important that it's grounded because the VFD generates some transient voltages. You can see here what the original interface looked like, for comparison. That was sitting on there. So I'd basically, in order to mount that VFD, I stalled on this project for a long time because, first of all, my wife and I, we had twins a couple weeks after I got all the materials for this, and that kind of consumed me for the last year or so. But also, I couldn't initially think of a good way to mount the VFD to the press here, or to the frame. And so today I came out here and I was like, man, I want to clean up my workbench, and this was sitting on there. And I just thought, okay, what's the easiest way I could do to possibly mount this thing? And then I found a piece of plywood, and oh shoot, in hindsight it was obvious, just get a piece of plywood and mount the plywood to the frame there, and then mount this thing to the plywood, and it worked really, really well actually. And that's probably, I should have just done that a long time ago. That's pretty much the exact, and I like it. It doesn't stick out that far. It's kind of compact. I think what I'll probably do is wrap this up in electrical tape, just to kind of clean it up just a little bit. But yeah, there it is. Relatively inexpensive VFD controlled drill press, and homemade at that. So anyways, hope you enjoyed watching.